We have a sample problem here. The motion of a piston in an auto engine is simple harmonic. If the piston travels back and forth over a distance of 10 centimeters and the piston has a mass of 1.5 kilograms, what is the maximum speed of the piston and the maximum force acting on the piston when the engine is running at 4,200 RPM? All right, so what do we know here? Simple harmonic, this means it's going through ideal oscillations. It's traveling back and forth over a distance of 10 centimeters. So if it's going back and forth over this, if we were to graph its motion, however it started, this distance is 10 centimeters. So that means the amplitude of the motion is 5 centimeters. We are going to assume the numbers given in the problem are significant to however many are shown. So we're going to assume that 10 centimeters is significant to 2 sig figs. And that's why I wrote A as 5.0 centimeters. We're told that the piston has a mass of 1.5 kilograms. And then the other number given to us is the 4,200 RPM, if you remember, is revolutions per minute. If we convert this to radians per second, it will be our angular frequency, our omega. So 1 revolution has 2 pi radians. So that cancels our revolutions out. We want to get our minutes into seconds, so our minutes cancel. So let's see. One of the zeros cancels. 2 goes into 6 3 times. 3 into 420. So we have omega is 140 pi radians per second. So we have 3 pieces of information. Coming back to what we want to find, maximum speed, so Vmax, and maximum force. So Vmax we have found to be omega times A. Well, we now know omega. It does need to be in radians per second here. A, our amplitude. If we leave this as 5 centimeters, our units for our maximum speed will be in centimeters per second. So let's see what we come up with here. 140 pi times 5 would be 700 pi. We don't have exact values, so we do want to give our answers in terms of decimals. Now, with this being such a big number, I'm not going to leave it in centimeters. So Vmax will be 22 meters per second. Now again, the units, we have centimeters here and radians per second. That's where the centimeters per second comes from. The radians, remember, are not a true unit, so we can write them or not write them. We typically do not write them as part of the answer when we're talking about a speed. So the maximum speed of this piston would be 22 meters per second. Now, maximum force, we do need to recall Newton's laws that force is mass times acceleration. If the force is maximum, then the acceleration is also maximum. So maximum acceleration, we know, is omega squared times A. So we can say the maximum force will be mass times omega squared times A. So mass we know is 1.5 kilograms. Omega we know is 140 pi. That needs to be squared. And then A, I'm going to go ahead and put our amplitude in meters to begin with, which I could have done when finding the maximum speed as well. So 1.5. So my calculator is showing me a lot of numbers. So essentially 15 kilo for the prefix, coming up my 3 decimal places. Units, we have the kilograms from the mass. Omega is radians per second squared, so we'll have the second squared there, and then the meters. So kilogram meter per second squared is a Newton. So we could say that the maximum force on the piston is 15 kilonewtons. And that force is maximum when the acceleration is maximum, which is when it's at its maximum displacement, all the way at either end of its motion.